Hey guys, welcome to your video on basic transformations of sine and cosine functions. This video is going to include topics of general equations for these functions, specifically on amplitude, period, vertical shifts, graphing these functions, and domain and range. So let's talk about these functions, sine and cosine. This is probably two of the most applicable transformational functions that we get to in Math 3. Radio waves, microwaves, infrared waves, gamma, light on the light spectrum, positions of time for wheels and bicycles, music and how you can make things quieter or louder, deeper or higher pitch for my vocalists and my musicians, even in nature with the sun and the moons. These functions can be found absolutely everywhere. So, since they are so important and since they can be found in the real world, amongst our other functions, whether or not you believe it, let's get more acquainted. So our sine function is probably the first one that you've heard of. It typically starts here. It doesn't really have a start or a stop, but we kind of think of it as starting here at the origin. It will go for a period of 2 pi, so it will stop here. And this is what we consider one wave cycle, or one period. So a period for both, actually, the sine and cosine function is 2 pi. The amplitude, how high or how low it can get, in this case for the parent function, is 1. So it's going to come up to 1, back down to pi, back down, and then back up again, and create this wave-like motion. And it would continue on and on forever, which brings us back to domain and range. So there's no x value. I know that you see all of these have pi's in them. And typically when we're dealing with radians, we deal in pi because it's a lot easier to graph. And that's what we're going to be dealing with today. But domain, there's no x value that I can plug into this function that isn't going to be on this graph. Now your range is going to change depending on your equation or your function. So notice I have Vs minus amplitude and Vs plus amplitude, and we have brackets because these will be inclusive values. So this is going to be your vertical shift minus your amplitude and your vertical shift plus your amplitude. This will make a lot more sense later on in the video, and I promise you we'll come back to it. But this stuff really is not that difficult. Let's go ahead and look at your cosine function. It starts, notice, we're going to flip back real quick. Notice your sine started at the origin and kind of did this whole one little wave motion. Your cosine is a little bit shifted. It starts here up at the 1, comes down, and back up. So this little dip is considered one period or one wave cycle for the cosine function. So it's a little bit shifted. I know you can kind of see a sine curve in this, and we could create a sine curve that would look just like the same function, but cosine of x strictly goes ahead and starts out just like this. Your period is the same, your range is the same, your amplitude is the same. All of these things are typically the same for your sine and cosine function. It's just where they start off on the graph. So now that we've gotten a little bit more acquainted with what they look like, let's look at the equations for these. So our general equations are going to look like this. Y equals A out in front, sine of B in front of X, X minus C plus D. Now notice plus D is on the outside. A, the absolute value of A is going to be your amplitude. Just like our regular transformations, if A is negative, it's just going to flip it across the x-axis and be inverted and just do exactly the same thing. It's not often you find that, but you can. It's not impossible. Most of the ones we're going to deal with today will not have that negative, though. So your amplitude is how high or low from the midline of the graph. So we're going to flip So the midline for this one is going to be the x-axis. Same with your sine function. This would be your midline. Once we start graphing these, I will help you guys draw a midline that will help you draw the graph better, and it will make a lot more sense. So A is your amplitude, your period, how long your wavelength is, typically is 2 pi. Now, if it changes, if this B in front of your x or in front of your theta is just x, changes, we're going to find the period by taking 2 pi and dividing it by theta. Okay, and it's the distance required for the function to complete one full wave cycle or wavelength. Your horizontal shift is moving left or right, so that would be like your h value, and then d is going to be a lot like your k value. Now, Math 3, we just get a general introduction into these functions, and we will not be dealing with a horizontal shift, but we will be dealing with the amplitude period and your vertical shifts. So let's start looking at what these things do once we start changing some of these variables. We're going to turn our function on. So we have the sine function. I have changed the window, -3 pi. I might have done 5 pi. -5 pi. Yep. 5 pi. We're going to do our x scale just means what we're going to count by. So let's do pi over 2. As soon as we move it, it changes to all those decimals. Our x min -5, y min +5, y scale we're going to count by 1. So if we graph this, we can see our sine function. It starts at the origin. We can see our one full wavelength here. Now, let's say we want to change this a value out in front. Let's say we want 3 sine, so 3 sine x. And I'm going to go and make sure that in my mode right here, I'm in my radians. I'm going to hit graph. You don't have to do that every time. It just, you need to make sure you're in radians. If you're counting in radians or degrees, if you're counting in degrees. So what did it do? It multiplied that height by 3. So now instead of being at 1, I have increased the amplitude of each wave by 3. So that's where that how high or how low. So now it's going up to 1, 2, 3, and -3 down below. So this is where that domain of all reals, and then our range would be -3 to +3. That's all where my y values would be. Similarly, if we were to do 1/2, fractions go in parentheses, a sine x, notice it has that theta symbol, all the same thing. Graph, so there's our original function, sine x. And then our new function, half of sine x. So it takes that height and divides by 2. Okay, so amplitude is affecting how high or how low our waves are going to go. Now this period changes things a little bit differently as well. Let's do sine of, let's do 2x. Make it real simple. Graph. So there's our original function, and now we're going to take that period and kind of divide it by 2, because we would take 2 pi over 2 is just going to leave me with pi. So now, instead of it going all the way out to 2 pi, it's going to have that same swooping motion, that same wave, in half of the amount of time. So it's going to be a lot more condensed. Think of like a coil or a spring being compressed and squished. That's kind of what that function is doing. We can really see it if we want to change it to maybe 4. So it would be a fourth as much, and it's a lot tighter. We're doing the same wave motion, but in a fourth of the time. Now we said the horizontal shifts we're not really going to deal with. That's just going to move your function left or right. However, our vertical shifts up or down, x, if we do, let's say, minus 3, doesn't make a difference. So there's our original function, and now we're going to take that original function and just move it down 3. That's all that's doing. So the function hasn't changed. We are literally just shifting it down by 3. Now again, all of these same transformations apply to cosine. It's just a different function as to where it starts. So if we do cosine of x, same kind of wavelength, but notice it starts here up at 1 instead of at the origin, but it's got that same wave motion. 3 cosine x, if we change just the amplitude, gets 3 times as tall. Same thing if we do, maybe instead of doing half the time, maybe we do it divide by 3, so it'd be 1/3. So there's our original function. We're doing a couple of things all at one time. We changed the amplitude and we changed our period. So now not only is it going to be bigger, but it's also going to take more time to get our full period, our full wavelength, because we would take that 2 pi and divide by 1/3. So now our period is going to be 6 pi, and it's going to take even longer to get all the way out. So that's kind of what a combination of these things will look like. So let's get into some examples. Find the amplitude, period, and vertical shift. So I'm giving you a function, and all I want you to do is find these things. We'll get to graphing in just a minute. So the amplitude, if you remember, is out in front of your trigonometric function. So our amplitude in this case is just going to be 6. The period, I want to take whatever's in front of x or in front of theta, same thing, and take that 2 pi and divide by that number. So 2 pi divided by 2 is just going to give us that pi. Your vertical shift would be a plus or minus out here after the theta or the x. So in this case, we have none. And that's all for this one function. Example 2, amplitude is out in front. 2, period, same concept. I'm going to take 2 pi and divide by that 1/4, because it would be 1/4 theta. So once we take that 2 pi divided by 1/4, it multiplies out to give you 8. So it would be 8 pi. So this would be 4 times that wavelength and would give you that really big, long, more smushed look. And vertical shift, we have no plus or minus, so that's going to be none for this one as well. All right, now we're going to add in some more stuff. It looks a little bit more complicated, but fear not, it's all right. Our amplitude is still in the same place, 5. Our period, we want to take this 2 pi and divide by 6, because that is our b value. So 2 pi divided by 6 is pi over 3. So we're going to have that same wavelength, but only in a smaller amount of time. And a vertical shift, we're moving up 1. So it'd be a plus 1. So our midline would start at positive 1 on the y. Example 4, our amplitude is 1/10. Period, I'm going to take 2 pi and divide by that 1/5, and it's going to give us 10 pi. So it's going to be 5 times as much as it was before. So it's going to be a whole lot longer and a little bit slower. That's okay. Vertical shift minus 3 out here on the end. Okay, so these are our equations. Graphing the functions. So let's start by picking out all of our stuff. Then we'll graph it. Then we'll come back to our domain and range. Amplitude is still out front, so how high or low is going to come up to 1/2. Our period, there's 1 out in front, so 2 pi divided by 1 is just going to go all the way to 2 pi. And there is no vertical shift, because it does not move up or down. So let's start this out. This is a sine function, so it's going to start at the origin. Our period is 2 pi, so 2 pi is where we're going to end. You kind of mark your beginning and your end. It makes it a whole lot easier. Your middle point from there is where it's going to come back down. So it's going to come up, down, hit the midline, go down to meet the other side of the amplitude and come back up. So from here, halfway in between there, we can go up to your amplitude, and that is what we call our crest or our peak. And then halfway in between this last part is going to be our trough. And now we can kind of see that curved line. So we would have something like this. Hopefully yours will look a little bit better. Now, of course, because it is a sine function, it would keep on going. So at the next point, we would be back up here, and then we would be back down here. And it would keep on going. But the main part to get us started is this piece right here. Now our domain and range. Domain, as we said, all x values. So negative infinity to infinity. Now your range would be your vertical shift minus your amplitude, vertical shift plus your amplitude. Or you can just look at it. We started from the bottom and now we're up here. So negative 1/2 up to positive 1/2. If you want to use the decimals, that is perfectly okay. All of that is acceptable. New function, and we've added this period shift in here. Now we're doing cosine though, okay? So amplitude found in the same spot, 1/2. Period, we're going to take 2 pi and divide by 4. That's going to give us 1/2. So we're going to start up at the amplitude, and we're going to stop at the end of our period, and then we'll have to mark it in between. Vertical shift, there is no plus or minus, so there is none, and then we'll come back to our domain and range. So if you remember, our cosine starts up at the amplitude and ends up at the amplitude. So pi over 2 was the end of our period, so that's where it's going to start and stop. Halfway in between, it's going to go down to our amplitude, so we can kind of see this curve right here. Halfway in between here is at our midline, and halfway in between here is at our midline again. So now we can draw this a whole lot easier. And we're going to start up at our amplitude, come down, and come back up. Now this one would be a whole lot tighter. The next one would come down at our midline here and be back down here. And so on and so forth. If you wanted to draw it all the way out, but I wanted to get you started right here with this main one. So our domain, because these would be arrows, again, always negative infinity to infinity. Your range, we can visually see it, negative 1/2 to positive 1/2. We had no vertical shift that would change that. So this is your cosine function. I know it's not very artistic, but it makes that kind of trough dip curve. All right. Now with our example 3, we see that we're going to have a vertical shift. We're going to start with our amplitude. Number out front, that doesn't change. Our period, we're going to take 2 pi, divide by 1/4. That's going to give us 8 pi. That's where we're going to stop. Then our vertical shift is at -2. So we can go ahead and draw what we were calling our midline. So I'm going to go ahead and draw one, but I'm going to draw a better one at -2. So instead of, remember we were saying that we would start at the origin or start up at the amplitude. That works if your vertical shift is at 0. Now we got to be a little bit more careful. All right, so let's get drawing. We're doing cosine, so we're going to start up at the amplitude, but we have to pay attention to our vertical shift. We went down 2. So from our midline, we're going to count up that amplitude. So 1, 2, 3 at 8 pi at the amplitude because we're at cosine. We're going to draw our endpoint halfway in between. So 8 pi divided by 2 would be 4 pi. We're going to be at the other end. So 1, 2, 3. So 4 pi -5 because I counted the amplitude the other direction from my midline and halfway in between there. Now halfway between 0 and 4 pi, so at 2 pi, I'm going to be at the midline, and halfway between 4 pi and 8 pi, at 6 pi, I'm going to be at the midline again. So you can start to see how this curve is going to get a little bit bigger when we start adding some amplitude and some vertical shifts. So now, hopefully, we can draw it a little bit better. That's better, right? So that is our beginning first piece of the cosine. Now, once we start getting better at it, we can add our other pieces. 2 pi more, we would be back down. So this would start coming back around, and that would be our cosine function, filling out the rest of it. Again, domain, easy peasy, negative infinity to infinity always. Your range, this is where your vertical shift plus or minus your amplitude comes in. So what we did, remember we took that -2 and we subtracted our amplitude. So vertical shift minus your amplitude, -2 minus 3, gives us that -5, and we can see that visually. Then our vertical shift plus our amplitude, so -2 plus 3, gets us back up at 1. And that's where we were. So this is specifically what the VS, or your vertical shift minus your amplitude, and vertical shift plus your amplitude was talking about. It kind of makes things a lot simpler considering we're talking about your graph, but you can also see your range visually as well. Last example for you guys. Your amplitude, 4, is your number out in front. Period. I'm going to take our 2 pi, divide by 1/2. So we're going to be at 4 pi. Vertical shift, we're moving up 1. So let's go ahead and draw our dotted line at our new midline. I promise this is going to make things a whole lot easier for you guys. Okay. Now we're talking about sine, so it's going to start at the midline. Nope. That's a little too big. Okay. So it's going to start at the midline, or what would have been our origin. We're going to stop at 4 pi on the midline. Halfway in between, is going to be at our midline again. Halfway in between here is going to be our peak, or our crest, and we're going to go up to 4. So 1, 2, 3, 4. Halfway in between here at 3 pi, we're going to go down 4. 1, 2, 3, 4, because that's our amplitude. Now we can start to see our nice sine curve right here. So let's get drawing. Make sure we pick up those points. And then, of course, we can always take it out a little bit further. So back up at 5 and then back down at 6 would be the rest of that function. But really the main one wavelength is that piece that we first draw. Domain and range, you guessed it. Range, our vertical shift minus our amplitude, so 1 minus 4 gets us at that -3, which we can see right here, inclusive. And then that +1 plus 4 gets us back up to 5. I hope I have made these equations and graphs really easy for you guys. If you have any questions, please don't hesitate to ask me, Miss Mann, Miss Henchman, or Miss Jennings. We would love to help you guys with this last piece. Happy graphing.